Okay, so we're going to talk about something called EPOC and oxygen deficit. All right, and how we handle both of these. So here are the two objectives or topics for today. So we got this figure here, okay, and we're just saying that we're going to go from rest to some intensity, okay, and we're going to say that we work at constant intensity. So it's just like when I go home today, I'm going to go run. I'm running about 8:45 minute miles when I go for my long runs. So it'll take me a little while to get to where I'm meeting demand, oxygen demand. All right. And so even though immediately I go from I'm sitting on the couch and then I go start running, and pretty quick I'm at 8:45 minute per miles. Okay. This leads to what we call an oxygen deficit. Now, as soon as I stop exercising, I'm breathing more than I need, right? So in essence, I'm hyperventilating, okay? Because once I stop exercising, the demand has gone down. My demand when I rest is very different than when I'm running. And so this leads to something called excess post-exercise oxygen consumption, or EPOC. So we're going to talk about both of these things. So oxygen deficit. So when we go from rest to some level of intensity, or from a level of intensity to a greater level of intensity, that requires more oxygen. We need to take in more oxygen. The problem is we can't immediately start taking up that amount of oxygen. There's a little bit of a lag, okay? But we need energy. And so if we don't have any energy, we're not able to do the work. But as you all know, because you've all experienced this in some case, and many times, like just going from sitting down to I'm going to go run to the couch or run to the fridge and get a pint of Ben and Jerry's or whatever, that requires energy, okay? But it takes time. And so when we're in this oxygen deficit, we are producing ATP via oxygen, oxidative systems, but we're not producing enough. And so we have the ability to kind of pay for this deficit by using anaerobic systems. It doesn't need oxygen, so it's immediately there. But you have to remember those anaerobic systems, they don't last for very long. Okay, we can deplete those resources rather quickly. And so over a couple of minutes, anywhere from 3 to 5 or 1 to 5, we eventually get to where we're bringing in enough oxygen, we're delivering enough oxygen, we're taking up enough oxygen. Okay, and so once we do that, we've hit that steady state, which we talked about in the last video. Now, at the end of exercise, we have this EPOC. Now, if you look, not only are you breathing more, but you're still taking up more oxygen than what you actually need, and this is in an effort to get your body back to normal. Okay, and there's a couple of components to it. So this fast component is when we're replenishing our phosphocreatine stores. Okay, and at the same time, our blood and our muscle have the ability to store oxygen, so we're replacing those as well. Okay, even though in that moment we don't require more oxygen. Okay, but then we have this slow component. So for several minutes, your heart rate's increased, your breathing's increased. Okay, and that requires energy. Your body temperature's higher than normal. Well, that speeds up chemical reactions. Okay, so that could be a component of why we're using more oxygen than what we normally would. The fact that there's epinephrine floating around, right, that takes a little while to clear out. That can also increase your metabolic rate. And it's possible that this excess oxygen that we're using comes from creating glucose from lactate. Okay, so as a result, even though it doesn't seem like we're doing more work, we actually are doing more work. And so I hope that doesn't seem like a conundrum or something that's contradictory from what I was saying just earlier. Okay, if we just look at if it was just apples to apples, I go from I'm exercising from rest to exercise and rest, well, the energy demands are the same at rest. However, there's a couple other things that might actually alter this VO2. And so if I'm actually increasing or have other processes going on that maybe I didn't before I started exercising, that would contribute as well. The last thing I want to talk about is economy of effort. So this gives us an idea of how efficient we are, okay? So we think about it in terms of cars with miles per gallon. We think about what's your VO2 relative to your running speed, that sort of thing. Whenever you're doing an activity, it requires a specific amount of oxygen, and it will always require a given amount of oxygen. However, if you're more economical, you can be more efficient, okay? And so if you have a low VO2 for a given speed, that means you've got a good running economy. And the way that this changes is you just become more efficient. Okay. I want you, like if you watch football, so look at somebody like Tyreek Hill of the Chiefs. Okay. Look at how he runs and then compare that to when Peyton Manning or Tom Brady run. Okay. Who is more efficient? Who is smoother? Okay. In my opinion, it's Tyreek Hill. He just glides. Whereas Tom Brady, who is probably faster than me, almost definitely faster than me, it looks like he's lumbering along. And it's like he's never run in his entire life. Okay. But if you compare him to Tyreek Hill, Tom Brady has a much lower running economy. It's going to take him more energy to run a specific speed because he's not as efficient. Okay, and so one of the things that happens with training is that we become more efficient at movements, and so then we're able to better use the oxygen that's available to us.